In early March this year, a leaked document allegedly from inside OpenAI started circulating on the internet like wildfire. The document came from a Twitter account called Vancouver 1717, created in July 2023 with just 2 tweets. One saying AGI will be born in 2030, and the other containing this PDF file titled Q*info. The first line of the document is a real shocker, revealing OpenAI's plan to create AGI by 2027. AGI, unlike the currently prevalent narrow AI used for specific tasks, can perform general tasks like humans with the ability to think, learn, have consciousness and emotions. Many believe the arrival of AGI will mark the sci-fi scenario of AI taking over human jobs and lives. According to this Q*info file, OpenAI started training a multimodal model with 12.5 trillion parameters called Q* back in 2022. They completed the initial training of Q* in December 2023 but kept delaying the release due to the high computational costs. The current plan is to release GPT-8 using the Q* model in 2027, which will achieve AGI-level intelligence equivalent to a human with an IQ of 145. To put that in perspective, the average human IQ is around 100, and an IQ over 130 is considered genius level. Einstein had an IQ of 160, so an AI with 145 IQ would outperform the vast majority of humans intellectually. If this document is legit, AI has left humans only 3 years. While many netizens doubt the authenticity of the document, the mysterious Q* project was widely circulated online last November. That's around the time when OpenAI CEO and co-founder Sam Altman was briefly fired. The day before his firing, Altman made cryptic comments at an event like, "Is this a tool we created or a being we created? This will be our biggest update." Many interpreted it as OpenAI having created AGI. 4 days after Altman's firing, OpenAI's secret AI model Q* was leaked, with rumors that Altman's dismissal was due to disagreements over the Q* project with other OpenAI executives. This explosive news makes one wonder just how far has AI development come. If the metaverse and Web 3.0 we discussed earlier had an element of hype, AI is undoubtedly a real technological revolution. Anyone with even a bit of foresight can sense that we're at the pivotal point of a once-in-a-century shift. Some say future AGI will destroy humanity, while others dismiss current AI as trivial and not worth fearing. Today, let's delve into the past and future of artificial intelligence. To get a clear picture of AI's future, we gotta look back at its past, because learning from history is the key to predicting what's coming, right? And when we talk about the birth of AI, there's no way around the Turing test. Back in 1950, before the first commercial computer was even built, this British computer scientist and mathematician named Alan Turing wrote a paper called Computing Machinery and Intelligence. In it, he proposed a method for determining if a machine has intelligence. It was 6 years before the term artificial intelligence was even coined. The Turing test was actually just a thought experiment. Here's how it works. You've got a machine, let's call it A, and a normal human, B. An evaluator, a human we'll call C, can't see A or B, but can ask them questions. If after questioning them, C can't tell which one is the machine and which is the human, then the machine has passed the Turing test. Turing's view was that if we can't distinguish a machine from a human, then we can't deny that the machine is thinking. What happened next was probably something even Turing himself didn't expect. 4 years after the Turing test was proposed, Turing passed away. But in the decades that followed, the Turing test evolved into a crucial benchmark for measuring AI intelligence development. It became the North Star of the AI world, with generation after generation of researchers eager to have their new programs pass the test. In the 1960s, the Association for Computing Machinery, ACM, even established the Turing Award to honor individuals who made outstanding contributions to computer science. In August 1956, John McCarthy, an assistant professor of mathematics at Dartmouth College, and later the 1971 Turing Award winner, along with Claude Shannon, the father of information theory, and others organized a 2-month workshop. The topic, which seemed far removed from everyday life back then, was how to make machines mimic human learning and other aspects of intelligence. The workshop was held at the quiet Dartmouth College in Hanover, New Hampshire, so it became known as the Dartmouth Conference. Before the conference, to get funding from the Rockefeller Foundation, McCarthy and his colleagues had to come up with a fancy name for their topic, artificial intelligence. And just like that, the term was born. The year 1956, when the Dartmouth Conference was held, is considered by many to be the birth year of AI. In the 20 years following the conference, AI saw its first golden age, with various schools of thought and research directions flourishing. In the nascent days of AI, several schools of thought emerged due to the ambiguity surrounding the field's positioning. The three dominant ones were symbolism, connectionism, and behaviorism. The symbolist school emphasized representing knowledge as symbols and logic, aiming to automate logical reasoning. The connectionists modeled the human brain's neural connections, constructing artificial neural networks to generate intelligence. The behaviorists focused on mimicking human behavior, believing AI emerges from the system's interaction with its environment. Initially, the symbolists dominated, being considered the first generation of AI. They believed human cognition's basic units were symbols and aimed to symbolize all knowledge into a comprehensive knowledge crystal ball to reason and solve any unknown problem. However, symbolist AI struggled with unstructured data like natural language and images. The connectionists, inspired by the human brain's neural networks, could process unstructured data better than symbolists. Their neural network algorithms mimicked the brain's neuron connections and activation patterns to learn and make decisions, addressing symbolists' limitations. The behaviorists, also called evolutionists, argued that intelligence arises from perceiving the environment and reacting accordingly, like biological intelligence evolving through interaction with the environment. Simple robots like vacuum cleaners and industrial robotic arms exemplify this approach. After an initial flourish from 1956 to 1974, AI research faced two winters due to factors like a critical report on its progress. The symbolists initially dominated, but the connectionists, with deep learning, have become prominent today, while the behaviorists have contributed to narrow applications like robots. AI has had a pretty wild ride over the decades. Back in the 1950s, scientists were super hyped about the potential of artificial intelligence. A famous computer guy named Herbert Simon boldly claimed that in just 10 years, computers would be able to beat the world chess champ. Yeah, that prediction was way off. The thing is, early AI systems relied heavily on brute computational force to crunch through all the possible moves in a game like chess. But the computers back then were laughably weak compared to today's smartphones. It was like using a plastic fork to eat a steak. So all these overly ambitious goals led to a bunch of failed projects and dashed hopes in the 60s and 70s. Funding dried up and AI research went into a deep freeze for years, the first AI winter. It wasn't until expert systems like one made for DC in 1980 that AI started thawing out again. But expert systems had their own issues: high maintenance costs, limited scope, etc. The hype faded again by the late 80s, leading to a second AI winter. Until 1997, that is, when Deep Blue finally made good on that decades-old boast by beating chess wizard Garry Kasparov. Deep Blue's victory showed the power of modern computing muscle, but it was really just an advanced calculator following rules, not true intelligent reasoning. The real game changers were developing in parallel: the neural network approach pioneered by Geoffrey Hinton, and the reinforcement learning technique used in systems like AlphaGo. By combining these methods, AI could actually learn and strategize more like humans instead of just brute forcing its way through. We're in a whole new era now where AI can even understand subtle humor and make clever jokes in response. So in a nutshell, AI went from insanely overhyped to disappointingly underbaked, not once but twice before finally living up to the dream in recent years. Who knows what wacky feats it'll pull off next? The release of ChatGPT by OpenAI in late 2022 marked the beginning of an AI explosion. Within weeks, ChatGPT gained over 1 million users, the fastest adoption rate for any application to date. OpenAI's valuation skyrocketed to $80 billion. When ChatGPT-4 launched in March 2023 with image input capabilities and improved performance, It raised concerns about the risks of rapidly advancing AI capabilities. A letter from the Future of Life Institute calling for a 6-month pause on AI systems more powerful than GPT-4 gained over 34,000 signatures, including tech leaders like Elon Musk and AI pioneer Geoffrey Hinton. Hinton later resigned from Google, expressing regrets about pursuing AI due to its potential risks, as covered in a New York Times profile titled "Why the Godfather of AI Fears What He's Built." The rapid AI race in 2022 to 2023 saw companies like Google, Microsoft, Anthropic, and Stability AI racing to develop powerful language models, image generators, music creators, and video engines. While potentially leading to breakthroughs, this race also raised existential concerns voiced by Musk, Hinton, and others about unbounded AI development potentially leading to human obsolescence. An OpenAI report suggested up to 19% of US jobs could face severe disruption from AI. Kai-Fu Lee argued creative, social, and negotiating roles may be among the last replaced, while routine labor is most vulnerable. While GPT-4 scored 41% on the Turing test, surpassing the 30% threshold, indicating an ability to mimic humans in language interactions, the test does not prove self-awareness or artificial general intelligence, AGI. However, the author argues we are at the dawn of a new era where current large language models, despite flaws, have developed capabilities once thought impossible and are primed for continuous learning, akin to how physics advanced from Newton to Einstein. The AI race may create breakthroughs or existential risks, but the author believes the anxiety it provokes could prompt valuable re-examination of human learning and growth. Referencing the original 1956 Dartmouth AI conference agenda to make machines use language, form abstractions, and concepts in ways that mimic humans, the author concludes that true existential risk is humans losing our drive for lifelong learning due to AI's emergence.